I would like to start to tell you a little bit about us. Medius is a Swedish company, and our vision is to be #1 in cloud-based invoice automation. So what this means is, first of all, that we are a cloud system that we sell to other companies. And second of all, what we help our customers with is invoice automation. And that means when you bought something, you get the invoice from your supplier, and our application helps our customers to streamline this process, basically. Let me see here. The company was founded about 18 years ago. We are currently 220 employees, but we aim to be around 260 in the end of this year. So we see things are going quite okay, so we see some growth here. So why am I here in Kraków? Well, about 10 years ago, one of the developers in one of our Swedish offices decided to move back to Poland because he's a Polish guy. And we didn't want to lose him as an employee, so instead it was decided that he would continue to work from Medius, but here from Kraków, and also that he would hire a few colleagues to form a small team. And this was a very successful experiment, and since then this small team has grown to 55 people, and currently this is actually the largest office of our Medius offices, basically. Right, sorry. Yes, and important also that this is really the backbone of our, the technical backbone of our company, so to say. And again, as many other companies, we are looking to grow a little bit, so please check our site for vacancies if you think that what we are doing sounds interesting. Okay, so let's move on to the topic of today. As mentioned, we at Medius was founded almost 20 years ago, and by then we created our software and we sold it as a license, and our customers installed it on premises, basically. But then about 2011 we decided that, well, this cloud thing looks really promising, so we decided to transition our business to cloud infrastructure instead. And this, of course, meant that we had to rethink a lot of the things that we were doing. So my idea with this talk is basically to tell about my learnings, my experience from these 7 years, and the most important things that I've seen when it comes to the area of DevOps. So we'll see how much time it will take. First of all, before I start, I would like to give a short disclaimer also. These things that I will present are things that I've seen as the manager for the cloud operation team. Other persons in our company might say that other things are more significant, etc., but this is my view. And second of all, these are true in the context of my company, Medius. I cannot say for sure that these will translate to what you are doing at your companies, but I will try to describe the background for my ideas, and then you can for yourself decide if they are valid for you as well or not. Yes. So, first question, what I've learned about organizing DevOps work. Well, most importantly, DevOps work is not something that you do once and you're finished with. It's something that you do for a long time and need to continue with, basically. I see it as a continuous stream of work that will never really finish. There might be times when you will do a little bit less, or you are able to do a little bit less, and there might be times that when you have to do a lot more, but you can never really stop this work. Yes, and Therefore, the best structure, as I see, for doing this type of work is to do it in the context of a team. So what do I mean by that? Basically a group of people, let's call it pizza size, like 4 to 5, or 4 to 8 maybe, that works together towards a common goal over an extended period of time. Notice, however, that I'm not saying that DevOps must be the only goal of this team. It can be one of many. I will get into that a little bit further in the future. Second thing, what is needed for teams to work well? Well, I think these aspects are really important, both when it comes to DevOps, but also when it comes to teams in general, actually. I think they need to be accountable for something so that they have a clear purpose in what they are doing. I think they need to have an autonomy in deciding how they can solve their tasks, so to say. And I also see that it's really valuable if the team see the results of their work, meaning that they have a short feedback loop. From my experience, this is the most important component in building a culture of continuous improvement, that you can really see what you do and see the results. Home in Stockholm, where I live, I usually walk to my office about 30 minutes each day. So the best days in my work is when I can think about the purpose of our team, have some ideas about improvement, come to the office, discuss and refine with the team, make an implementation, and then evaluate the outcomes on the way back home. So if we have an organization that supports that kind of work, I think that's a way to be successful. So, how do we organize DevOps work at Medius? Starting from the beginning, as I mentioned, we were building this product, and therefore we had a couple of development teams. But then, when we transitioned to this cloud service, suddenly we became responsible for a lot of more stuff. Meaning deploying our software, meaning managing incidents, meaning infrastructure, backup service requests, and more things actually. So our first instinct here, a couple of years ago, was to say that, okay, let's create a new team for this, which became the cloud operations team, and this is the team that I've been team lead for. So what worked well in this organization? Well, each of these teams can focus on their things. They have a clear purpose. And we were actually able to get quite good results, or really good results, I would say this way. The development teams building really good things in the product, and us in the operations team, we were able to improve a lot when it comes to how we deploy software, how we manage incidents, etc., etc. But unfortunately, there is a small but here, and it goes back to what I mentioned about being accountable, having autonomy, and a short feedback loop. Because even though our development teams have always been very, helpful and mindful about operations work, there is still a divide between us where we are accountable for having the product running, and they don't have that at the same way. And that means that, basically we have been able to improve our scripts, etc., in a quick pace, but not as quickly when the solution lay in the product, in the software, so to say. So then we had the second edition, because we introduced a few new products to the market, and we decided to build them a little bit differently. So in this case, we gave the development teams much more responsibility. Instead of just building the features, we also said that, hey, development team, you need to think about how the operation will work, and actually also be involved in solving the incident, making the deployments, etc., etc. So here we work more with an end-to-end responsibility for these development teams. And then you might ask yourself, okay, what are we doing then as a cloud operation team? Are we not needed anymore? My answer to that question is no, we are still needed, but we need to refine our mission slightly. So instead of focusing on making the deployment, handling the incidents, etc., our mission now is to help the development teams to be as good as possible in their area. And we do this by providing tools to them and by providing services to them that basically makes their job easier in all of these areas. So, what I've learned about implementing DevOps as kind of a service. We needed to do a little bit of a mind shift here. So from doing more traditional operation work, we are now treating what we do more as a product. So this means that we borrow a lot of methodology from the development, process, basically. We don't have a specific product owner role, or a specific product owner person, I would rather say, but we still have that role, and that's something that I have as part of a team lead. And that means that I need to go to the development team, I need to understand their situation, and I need to thereafter prioritize our backlog for improvements, what we can do differently to help them. Also, when they come to the process within our team, we are doing most of our improvements as a, development workflow. We are working with Kanban boards, we have a prioritized backlog, we write stories with motivation and acceptance criteria, then we implement these services or improvements to them in code. And of course we do like review, we work with source control, etc., etc. So we kind of learn from the development process in how to work this way. Another thing that we really like is self-service. This is partly from our perspective, of course, that we don't want to have to be involved every time that someone, say a development team or other consumer wants to use our services. Because then we can spend our work in improvements instead. But I think it's also a much better user experience. I mean, placing a ticket for a separate team and waiting for them to pick it up, etc., it's usually not the best user experience. So what we instead aim to do is to let other teams use our services without us being involved. So how do we do that then? Well, we built upon the knowledge that we've had and have. And we really like scripting, so most of our things are actually built on PowerShell. Unfortunately, PowerShell doesn't have a great UI if you are like a consumer that is not a developer or something. So to have a web UI, we are running these scripts by Jenkins, and that helps us both with scheduling, but also gives a user interface so that we can define a new Jenkins job, we can have a script in the background, and then we can have a development team, for example, using that, say, to create a copy of a database or whatever we want to help them with. So this is a platform that we are using a lot. I don't have much knowledge, to be honest, how other companies are doing this. So if you have the same kind of setup, I would be interested in knowing what kind of tools you're using to make this happen in a nice way. Yes. Moving on to infrastructure then. What I've learned about using cloud infrastructure. Well, first of all, we really like to make it someone else's problem. And this is not referring to giving it to the development teams, actually. This means to, from Medius' perspective, to make it someone else's problem. So what does it mean? Well, first of all, of course, as I assume many of you do, we use cloud service provider. In our case, that's Azure. So running the data centers is their problem. But we also heavily prefer to use platform as a service compared to infrastructure as a service, so that we can focus on the value of, again, invoice automation rather than patching servers. We are also very open to buying other SaaS services rather than building infrastructure ourselves. So that's something that we use quite a lot. Another important thing is that to be able to destroy and recreate rather than fix infrastructure. This is both helpful in troubleshooting when, actually, rather than trying to understand exactly what goes wrong, it has been more than one occasion where we have instead decided to just delete what we had, spin up a new instance, take the traffic there instead, and thereby solving the problem, basically. Obviously, this is also really helpful in a restore scenario. There are things that you must restore from backups, of course, but having things that can be spun up as new instead of from backups is really nice. What kind of implications this has? Well, you need to think about this in the architecture, of course, so that you separate the state of the application from the compute runtime, so to say. And also you really need to think about it from an operational perspective. We can never have a situation where we go into our infrastructure and do a lot of manual changes, because we always need to assume that the infrastructure will disappear and be recreated. So therefore, we are using a lot of infrastructure as code. We are doing this in Azure by ARM templates and also PowerShell script that we are using to deploy our infrastructure, basically. And that's also, of course, how we do changes. If we do a change, we need to do it in our code rather than do it manually. Last but not least, this one is a little bit simpler in the second edition of the organization I showed, because before it was a little bit of a struggle. Who will decide what infrastructure to use, basically? Maybe the development teams want to use something, but then in the operation team we need to maintain it. Now it's a little bit simpler in the second edition, because the development team are responsible for the operations as well, kind of. So if they choose to use something where we don't already have a knowledge that we are managing the service for them, then that's their choice, and they are responsible for handling it, basically. So what does it look like, Medius infrastructure, then, based on this? I will mention this is kind of our main service, but also the first one. So we have a couple of ones that we have built later on other technology. But this main one is built on, as I mentioned, platform as a service components. This is in Azure. You have web role, you have worker role. So I think this is actually one of the first compute platforms that they brought to this infrastructure. And then for data storage, we use SQL databases that are managed, again, by Microsoft, nothing that we take care of ourselves. And also blob storage, which is, of course, managed file storage, basically. Then again, as I mentioned already, we are really happy to buy services as well. So, for example, email. Logging was something that we used to do kind of in-house before, but we decided that, well, this is not really our core competency and stuff that we want to have. So instead we are buying that service, and these are just examples. And then last but not least, adding new types of infrastructure. Well, we had one scenario when the team was challenged with how to manage files, basically, that was imported. And the decision was that, well, this cloud service is not the best way of doing it. We want to basically compress the files and do some modification to the format. And in this case, it is, again, completely fine, as long as the team take care of the infrastructure, right, to introduce new components. In this case, it was the storage queue, and then they use Azure functions to have these files modified. Yeah, basically. So this looks quite nice and simple, and as I mentioned, we have the platform as a service components, we have some third-party components, we don't have infrastructure as a service, so nothing for us in cloud team to patch, etc. Well, unfortunately, the world is not really that simple. As it turns out, we have many of these clusters for several reasons. One of them being that we have customers in different geographical locations, so we need to have some in Europe, some in US, and on other locations. Another one is that we separate our customers' test environment from our customers' production environment, so that means that we have different clusters for that. And last but not least, we had initially, when we started to use the application, we had some limits in how many tenants we could deploy to each cluster. And therefore, let's say in Europe, for example, we actually have more than one production cluster setups. From an operational perspective, however, these ones are completely independent from each other, which is kind of nice, but the problem was when we needed to move tenants from one cluster to the other. Because basically you have one URL here, you have another URL there, and if you want to move the tenant, the URL will change. And that was not really something that our customers appreciated, both for their users, but also for the fact that our application is heavily integrated with ERP systems, meaning that these integration would need to be updated with new URLs, etc., if we move the application or if we move the tenant. So that was a little bit of a mess that we needed to get out of. So basically we decided that, okay, we need a component here in front that will do the routing, and this was a few years ago. Unfortunately, we couldn't find a platform as a service option then. I think there is one now in Azure actually called Application Gateway or something like this. But that's not something we have used ourselves. So instead, we implement an HA proxy, which is an open source reverse proxy, basically. So this infrastructure looks like this, that we have the Azure Traffic Manager, which is kind of a DNS load balancer that points the traffic to the correct location based on where the user is. And then we have load balancers on each location with regular VMs behind where this application is installed. And these VMs are something where we need to maintain operating system and everything like that. As I mentioned, I don't really like infrastructure as a service, but I do actually really like HA proxy. I think it's a very powerful component. So I wanted to describe it a little bit more in detail. Maybe first question, how many has experience with using HA proxy? A couple of people actually. So I will show very briefly just what it is, and then also how we are using it. Yes. Just first, it is a reverse proxy layer 4, layer 7. It's used by quite many big companies. But moving on to some examples. So this is just a simple example of an HA proxy config, and I would just use the configs to explain how it works. You have a global section with some global parameters, right? Like, for example, how in this case the SSL setup. Then you have a default section where you set default values like timeouts, etc. But then you have the front end where the request is coming in, and then you map it to backends, which is where the request will continue, basically. Looking at the front end in this case, it's bind to port 80 and port 443. And this first line, what we are doing is to redirect the request to HTTPS if it comes without HTTPS, basically, right? And then the task in this, again, very simple config file, is to route to an API server if it is a request to an API. And for that, we use something called an ACL, access control list. So this one is basically evaluated either to true or false, based on the conditions here. And then it's tested here with this use backend statement. So if this one is true, then it will go to this backend, otherwise it will continue. In this case, what we're looking for is path beginning equals API, and then we will go to the API backend, and otherwise we will continue to these web servers. And the web server implementation, once again here, quite simple. You have a round-robin load balancer, and then you have 2 servers in this case, and similar setup for the APIs. Let's see. So I want to show a little bit how we are doing this. And first of all, for routing of these tenants, we have a similar requirement actually for finding API requests, but our paths looks a little bit differently. So first we have the tenant name, and then we have /API. So here we use path regex instead to evaluate if this is true or false, basically. So here we see if it's an API request or not. Then we want to see which of our deployments these tenants belong to. So here we want to see true, false, if it belongs to Cloud 02, so meaning one of these deployments, basically. And again, we're using regex to check. But here we don't want to have each tenant name represented in the config file. That would be a mess to update. So instead we are pointing to a text file that contains 1 line for each tenant with basically the regex expression for this tenant, basically. So if this one evaluates to true, then this one will be true, and then it will be checked here. If also URL API is true, then it will go to MediusFlow Cloud 02 API backend. If Cloud 02 only is true, then it will go to MediusFlow Cloud 2 backend, and otherwise it will continue. And here we have many more deployments again, so we basically have a long list of deployments here with text files. And once again, these text files we use Jenkins to keep up to date. So if we add a tenant or if we move a tenant from Cloud 2 to Cloud 3, then we just produce new version of these text files, and then we push them to HA proxy, and then we do the routing that way. Our backend implementations are actually really simple, because in our case, we are pointing to platform as a service services, so we are not pointing to individual servers. And those have their own load balancers. So we are just using the DNS names here. And because the IPs will actually change, we let HA proxy resolve the IP addresses for these names. Yes, next example is the use case where we would like to add the ability to create a service window for our tenants. This can be something that we want to do in the cloud team, or it can be something that our customers are requesting for us. Again, we have tight integrations with the ERP system, so if they want to do like an upgrade of the ERP system, they might want to have a rollback opportunity, and then they want to ensure that our system has not like been modified based on that information, basically, in the ERP. So again, very simple. The request starts from the top, and we just add a new ACL if the URL belongs to a service window or not. And then again here we just add to the text file the list of the tenant names, or the regex expressions of the tenant names, basically. And again, this is also maintained by Jenkins, and we push these files out to HA proxy. Another one that we have seen useful, and we added quite recently actually, is that we wanted to be able to identify each request later from the backend systems as well. So of course in HA proxy we have logs for each request coming in with a lot of information like the time spent, the size, the IPs, etc., etc. But what we did here was in the default section we added this ID parameter, meaning that we have a unique ID being logged for each request. And then we are passing that on to the backends using this xUnique ID header in HTTP. So then the backends can decide to implement in their logging, also read this header and state it in the logs, and then we can see in logs which requests. Yeah, basically we can see the request both on the proxy, and we can see it on the backends as well. So that's something that's helpful for troubleshooting. Last but not least, something we can do in that we have done in HAProxy is that we saw that some search engines were implementing or were indexing some sites that we were not really happy about having indexed. And then I learned that there is something called an xrobots tag that you can set in the HTTP response, and if you set it to none, then the search engines will drop the index basically. This one is a little bit trickier because what we needed, because we wanted to evaluate when this header should be set, basically based on the host header on the incoming request. The problem is that this HTTP response is evaluated when the response comes back. So then this header does not exist anymore, or we don't have this, we don't have access to this request. So what we did here then is something that was introduced fairly recently, I think, in HAProxy, is the ability to set variables. So here we set the variable when the request comes in, called host, and it's for the scope of the transaction. And we set it to the value of the request header named host. So basically we save the host value in this variable. And then when the HTTP response comes back and this one is evaluated, we are not looking at the actual request header, but instead we are looking at this variable value. And again, we are doing a regex check here to see if this one is true or not. So in this case, we will set this xrobots tag non-header if the host header for the request is either cloud or dev or demo.mediusflow.com. Some things that we are not using it for, but we are considering, is rate limiting of APIs, for example. We can put the information in a, we can save the information basically for each IP, how many requests they are making to individual services, and thereby implement some limits when we don't want to accept the request anymore. However, that has turned out to be an issue more from the business perspective rather than the technical perspective, how that implementation should work. Maybe one more thing to add around this HAProxy is, as I mentioned, it's a very powerful tool, and we could actually rewrite requests in quite, how to say, creative ways. But we strive to keep this as simple as possible, and rather changing the backend systems. We are not using the powers of HAProxy to do a lot of modification here to avoid doing it in the backend system, because then we will have a very strict coupling between the HAProxy config and how the backends work. We prefer to have the backends, to have a simple HAProxy setup and then do the changes in the backends instead. Okay, so moving on to the next topic. What I've learned about deploying software, kind of a big one. First one, assume 100% responsibility. This is probably obvious for many people running a cloud service, but if you come from like enterprise software, and again, where we started was that basically when a customer wanted an upgrade, we sent our consultants there. Let's say it happened like once every second year or something. Then it was a long upgrade project, then it was probably customization written, and no one really knows if it worked or not. So basically, before we put it into production, we forced the customer to do a lot of testing and put their name somewhere saying that, yes, this is exactly what we want, right? But this is a mindset that we dropped when we moved to the cloud infrastructure, and I think that was important for us. So now instead, we are not assuming at all that the customer is doing any testing. We are taking care of this 100% ourselves. And actually we are not assuming even that the customers have like got any training about new features or even read the release notes. The idea is that the customer should be able to log in after an upgrade, and they should just be able to continue to use the application. Then of course it could be that if we have a new feature that requires some configuration or something, then they would need to read up a little bit to use it, but they should not be forced to learn, so to say, to just continue to use the application after an upgrade. Next, finding a good rhythm for releases we have found to be important as well. Again, we started with very slow upgrades in this on-premise world. So when we moved to cloud, we thought we were ambitious and said like, okay, let's go to monthly deployments. That sounds like a really tough target. And we worked with that for some time. But then we did some analysis, and the issue here that we see is how long time it takes from that the story is implemented in development until we get it out in production. So this is the cycle time in working days, and what we could see was, yeah, you see it's like average just below 30, meaning about 6 weeks or something. And going back to what makes a team work well, that's really not the situation where you're like thinking about the improvement, making the implementation and get the results the same day. Here instead you're waiting 6 weeks, and it means that when the feedback comes back, the development teams and maybe also the product owners have lost kind of the context of how they were working with this. So right now we have gone to weekly releases instead, or at least we are deploying every week to production. We are not yet doing continuous deployment. Maybe we'll get there someday, we'll see. But we have moved to weekly at least, so that has been a nice step forward. Last thing important when deploying software, and what it is a lot about, I would say, is to control risk, or what you can call blast radius. And the blast radius would be how many customers are impacted if something goes wrong when we deploy something new, right? Initially we were doing this, or basically we are still doing this in this way, that we do first basically staged rollouts, right? So we do a small release first, we validate the results, then we do a little bit of a larger release or to a larger set of customers, and then we validate the results again, and so on. Initially we only used these different deployments as I talked about as the tool for this. So we took like the first deployment first, maybe one of the test environments for the customers, and then one of the production environments, and then another production environment, and so on and so on. What we have done lately, on the other hand, is to start working a lot more with feature toggles in the code. And the nice thing with that is that we kind of decouple the actual releases from the features. So now instead of having this flow on the release level, we are able to, or rather the development team is able to, on a feature level, say that, okay, the feature has been released, but it's not yet enabled. And then they can enable it for like few customers, and then for few more customers, etc., etc. And it's no longer coupled to the release. And the nice thing with that is that the development teams that have built the feature, they have best knowledge about the risk, together with, maybe with the product owner that knows the customer. So they can take really accurate decision about what is the good risk management process for each feature, and it's owned by the development teams rather than by us rolling it out. Last slide actually, so I think I will make it in time. What I've learned about incidents and alerts. First of all, when we started out, we were sending alerts to, or we were measuring things, and then we were sending emails when it went wrong, something went wrong basically. What I should mention is that we are a distributed team. I'm based in Stockholm, and then many others, or the rest of the team actually, is based here in Kraków. So it was not always super clear who was actually working on the incident and taking care of it. So for us, a really nice solution here was to introduce a paging system. So that means that we get notification, of course, when something happens, and it also tells who is picking it up, etc. So that's something that has been useful for us. However, we try to be very restrictive what we alert about. I mean, when you have this capability, you can alert about anything, but we try to really focus on business or things that are close to the customer's business value, basically. So are they able to log into the application, etc. We are not generating alerts about, how to say, too many technical details. Rather, we look at the business stuff, and if that one starts to fail, that's when we start troubleshooting, basically. Another thing we have learned about during an incident is not to forget about communication. We are not using like any specific method like ITIL or something like this. I know, or I think at least, that there are like roles in that framework for like who will take care of the communication, etc. We are not doing that, but we have really learned that communication is really essential when things goes wrong. We do this by using a status page that is public to our customers. We do it by having and we also help ourselves by having like templates for how to publish information both internally and externally, so that everyone that are affected by an incident can see the status, basically. And last but not least, really important to learn something when things goes really wrong. We use blameless postmortems. We have not been great at it, I would say, a few years ago, but now we are doing it more and more, and I think it's really useful to get the people together involved and really figuring out what was the incident about, both looking at the communication patterns, were we communicating to the correct people, also how did we react, how did we resolve it, and also of course looking at some kind of root cause, what can be done to prevent this thing from happening again. That was actually all I have learned, I think, during this past 7 years. So thank you for listening.
Hi.
Hello.
Rafał speaking. You said that you are using Jenkins for deployment processes and automation. Mm-hmm. How is your architecture looks like? Do you have one Jenkins masters and slaves on each tenant, or you have different architecture of Jenkins?
Well, we have one Jenkins master, which is just a master. We don't run any jobs there, and then we have many nodes. As I said, we are not using this only for builds. We are using this for running a lot of scripts. So I think how many nodes do we have today? Is it like 65, something like this? So yeah, we are, and we are running one job per node, basically. We try not to have multiple jobs running on the same node, but yeah.
Do you use a single HA proxy in front of all of the clusters, or do you have HA proxy per cluster? Because I'm asking because the latency between locations might be significant, especially for API service.
We are not using a single HA proxy per cluster. We are running the HA proxy one as kind of a separate service, I guess you can say.
Okay, so for example, you have HA proxy in Europe, and then you send traffic from Europe to, for example, the client is in the United States, and the request goes to Europe, and then the backend request goes back to the cluster in the US.
No, I mean again, that's where we use the Azure Traffic Manager. So the request will go to the HA proxy location that is closest to the user, and thereafter it will go to the backend. So I mean, if the user is in US, then the request will go. So
there is more than one HA proxy.
Yes.
Okay. So one more question.
Yes.
Do you use any configuration management system, or another way? How do you bootstrap your servers?
You mean in HA proxy case?
No. I mean in general.
I mean, actually, we don't use like Puppet or Chef or anything like that. I mean, as I said, most of the things we use are platform as a service, and We haven't really seen that need. So we are using these ARM templates, right? And that's kind of the, not configuration system, I guess you can say, but that one describes the infrastructure, and you can actually execute some scripts, etc., from that one as well. But then we run scripts also. So we don't use like Puppet or Chef or Ansible or anything like that.
Okay, and what about configuration inside a virtual machine? Like, I'm not really a Windows guy, but probably you have to configure some stuff, install libraries, and push configuration files.
I mean, the main thing we use is these cloud services, the web role and the worker role, right? Mm-hmm. And there, basically, what we give to Microsoft or to Azure is a package with the code, and then they have a configuration file that basically tells which port should be opened, and also in that configuration file, it's possible to run some startup scripts, etc. So we use that, but again, we have really few virtual machines that we manage ourselves, really.
Let me understand this. Do you have any pre-built images, or do you make this process all over again every single time? So because if I understand correctly, you have a template file, and then you have some job in Jenkins that create for me 10 servers, and you click, and the magic happens. So, or you have pre-built images for your virtual machines, and the process goes just faster.
I mean, again, when it comes to our main service, what we do is to deploy these. We build the code packages, and then those are basically deployed to vanilla server, so to say. The only thing that is installed is these code packages, and then it is these, the configuration that belongs to it. There is no other configuration that will happen to these servers, basically.
Okay, that's good.
So keep it simple.
All right, thank you very much.
Thank you.
Hello, I have a question about alerts. Do you use any specific tool about for alerting?
For what?
Alerting.
We use Opsgenie as the alerting or paging system, so to say. Again, most alerts are actually generated in Jenkins. We are monitoring stuff there, and we are sending alerts from there. Some alerts we are also generating from Grafana. We use this for metrics. I'm not sure if you're aware of it, but visualization tools, and we send some alerts from that as well. But Opsgenie is the main alerting tool that we use.